where Tomasz is going to explain how to write extensions to Ruby using the D programming language.
Okay, am I heard? Is everything? Is the sound working? Anyone can hear me? Cool. Okay. So good evening, everyone. My name is Tomasz Stachewicz. I'm from Poland. I've been on Lightning Talk yesterday, so let's maybe cut off with the introduction. Can you see the 3 letters on the screen? That's good, because they're not letters. Okay. The original title of the submitted talk was RuDy, write Ruby native extensions in D programming language, but that was submitted in February. And between February and May, we had March and April. So I've changed the topic a bit. Well, we're going to focus a bit on performance, right? Performance is cool now in the Ruby community, as we all know from the recent Flame War. As we know from Matt's yesterday's keynote, that actually the biggest challenge ahead of Ruby is the performance. Oh, wait! And in order to make a good reference to the we all know which talk, we got to have some S on the screen. Okay, so we're going to talk a bit about combining performance and combining productivity with performance. Ruby still won't reach the performance of some compiled languages, and it doesn't mean that we have to write in C whether we want performance. But let's go with the rockstar metaphor for a bit. If you want to see the slides, by the way, and the codes that I'm going to show here, they're already on the interwebs. Let the routers melt. Okay, so let's talk about rockstars. Is your language a rockstar? What kind of rockstar our favorite or not favorite language can be? So your language can be pretty old, like 50 years old, having a now pretty small but very tight fan base, and being pretty consistent throughout all these years, and now being regarded classic but still pretty cool. On the other hand, your language can be also a pretty old one, not listened by anyone today. Actually, your language can be listened only by our parents, and being practically dead. And we could carry on. I've already made myself enough enemies with these 2 slides. So let's talk about metal. We want performance. Even Mats wants performance. We want performance even in our games. Even if we write games in Gosu, we could still be forced to write some number crunching in a very performant language, for example, to do some artificial intelligence. So we want metal, or at least close to. So what languages or what technologies are metal? So what metal star your language is? Now, your language can be kind of old, like from 70s, 60s, 70s, can be regarded classic, can be used by many people even today, but can turn out to be pretty crude and outdated if you try to use it today. That's what the case is with C. Your language can be claiming to be based on the previous one, but actually being completely Frankenstein and really out of its roots, and actually giving very hard meanings. Of course, yeah, you know what. So the sad thing is that no one's listening to hair metal today, but people are still using C++ today. Well, your language can also be very true, very hard, very metal. It can have a fan base of 5% of total programmers. Actually, they claim to be 100% because they don't consider other people programmers. Okay, but seriously, I've made myself enough enemies now. Let's try to find a language that's going to be modern, that's going to be cool, and that's still going to be metal, not in a new metal crap kind of way. Another set of enemies is going to arise. Oh, one more thing. Your language can also be popular in the 90s, doing some modern metal, being pretty cool, but even used by some people today, but actually being dead again, or non-existent. That's sad, actually. It could have been also many people's first language. So, there's a band you probably don't know about. It's not that I'm going to do any promotional video about them, but they are modern, they play metal, they're not very popular, but they are all-star. They combine some cool pieces of metal, of thrash, of death metal, of country, and they still feel tenacious and consistent. That's D. But what the hell D is? Well, let's maybe return to the C beat and let's try to walk our way to D. So there are many flavors of metal, and to sum it up about all the flavors of metal, let's see this one.
Metal comes in many different forms. Industrial metal, Scandinavian new metal, vegetarian progressive grindcore, black metal, super black metal, and lounge. Pick the most fuck off one you can!
So, let's reiterate on few of the languages. What's the main problems? Because now I got your attention, now we can get to the crunch, right? The main problem with writing extensions in Ruby, it's very simple. It's C. Don't get me wrong, it's like with Black Sabbath. I love Black Sabbath. I'm still sometimes listening to Black Sabbath, but if it was the only music I've been listening to, or if it was major music I'm listening to, I would be crazy by now. So, because see, the main problem is that switching from Ruby to C when you have to write a native extension and you're forced to, actually hurts. Because Ruby is object-oriented. Ruby has a garbage collector. Okay, I'll be waiting. Okay, so Ruby is object-oriented. Ruby has a garbage collection. Ruby has namespacing. Ruby has dynamic arrays, hashes, strings. Ruby has built-in almost support for unit testing, exceptions, dynamism. It only has poor performance. Now C, on the other hand, if you ever wrote a native extension, you should be crying now, not laughing. So why not use C++? And use the Ruby C API and all these features of C++, despite, of course, me mocking C++ and comparing it to hair metal. Well, because, actually the popularity speaks for itself. Do you know anyone who's been writing Ruby native extension using C++? It's like getting the worst of both worlds. And, to remind you how bad C++ is and to make myself some new enemies, I'm going to show you a classic quote that was kind of prophetic, and the worst thing is that it applied well to 1995, but it applied well also to 2005. That really did hurt. So, what option do we have if we're not really into the crudeness and the harshness of C? Remember, I love C. And we don't want this Frankenstein called C++. D. Well, D in one sentence is basically a language that C++ could have been, I don't know when, probably at some time could have been, a language that C++ should have been but will never be because of the bad design decisions and tight grip on being backwards compatible. So why D is cool and why you should use D, why D is the new metal star that you'll probably focus on and that's growing in popularity. Well, D is young. Actually, it started like in 2001, 2002. The first drafts of the specifications were published. First version was released like 2 years ago. So it's, you know, it's like Ruby 7 years ago, the cool red thing that no one knows about, and you could be one of the early adopters. This compiles, it's from the C family. It's compiling to the machine code. It has C++ performance already, after 2 years of being a language. C++ compilers have 20 years plus. It has productivity features inspired by languages like Ruby, Python, Java. It's binary linkable with C. So if you have a binary library written in C, you can interface with it from level of D. It's also the other way around. If you have a library written in D and you export the headers, you can use it from your C programs. So you could be like the only programmer writing in D in your company and still do it. So few features of D. Actually, they're not all the killer features. If someone was going to recommend you a language and squeeze all the features that would have to convince you on one slide, you'll drop the language. It wouldn't be worth it. So no, like of the singles, like the small things. So it has Java-inspired object-oriented programming. So with single inheritance, not this multi-inheritance crap for C++. It has interfaces. It has templates, but very, very well thought ones. And I'm going to show you a bit of real-world usage of templates in writing Ruby native extensions. It has mixins called indeed template mixins. That is snippets of code, some functions that you can add to an existing class without this class even knowing about it. It has some reflection metaprogramming, most of it compile time oriented, but some also runtime oriented. And some of it also pretty smartly pretending to be runtime, but actually, if you think about it logically, it could be done at compile time. It has dynamic resizable arrays. It has hash maps. It has strings as a kind of specially treated type, but that could be also used as arrays. It has garbage collection, which is kind of put off for some people, but the garbage collector indeed can be turned off and on at any moment. If you really want to do this real-time stuff, that could be interrupted by GC, or you can manually free some memory. So GC won't have to. GC will just remember not to even touch this memory if you thread it. D has also exceptions with scopes like try, catch, finally, and so on. D has native support for unit tests. And you know, I could like give you 5 another slides of these killer features, but what's the biggest killer feature for me is that in D I felt like home. On the other hand, everything worked like I expected it to work. It's very logical language, and it's very productive because every hour of working with it made me want to work more with it. I haven't felt like that since my first experiments with PHP. Okay, so how do I write Ruby extensions in D? Well, it's not that easy that you take a header file from C. You also have to prepare this file in a pretty usable for D way, because D doesn't read header files. So I started to do it. And this project, of course, started as a port of bindings of Ruby's C API, but later became very inspired by very productivity and de-exploiting features from PyD that Pythonists already have. Actually, author of PyD is one of the coolest guys in programming community I've ever known. And if you have a cool guy, you can't have a bad library written by him, right? So, what's so cool about RuDy? At first, you can write extensions in D just like you would in C. There's a bit of more lines in D because there's a declaration of the module. Because in D you don't have globals, you can only have modules. You can have globals if you explicitly import something as public. And D is a bit more restricted, so you have to first declare the function as not taking any arguments, because the define method RB is actually declared as taking a 0 argument function. But yeah, just bindings. I'm having like half an hour for this presentation, and I've only burned half of the time. They are not just bindings. bindings would be enough. I mean, I was so excited by bindings that I started hacking my own extensions in D. And I started to feel crappy because Ruby's CAP is great, but its biggest limitation is that it was designed for C. So, what are the other features? You know, if you've been writing some native extensions, you sometimes have to convert the values that you've created in C, especially after some number crunching, to a D value, to a Ruby value. So you know, so you have this fix to str, rb float new, which instantiates a new float from the double argument. You know, the integer, the Ruby integer from a C integer, and so on. And actually, there are 3 dots because because actually conversion methods make up for about 80% of Ruby's API. Well, RuDy has only one method to do it. It's called toRubyValue, and it's using a very logical trick, because D is a statically and strongly typed language, so the compiler at the compile time already knows what the type of given variable is. So it should also let me pass something and let the compiler decide which function to pass it to. So this is abusing or exploiting the templates feature from D. So we just have toRubyValue, and whatever kind of stuff you pass to it from D, it's going to return a valid reference to a Ruby object of proper type. It works the same for booleans, numbers, strings, array, hashes, etc. It's going to have also some cool features in nearest future. That's probably the youngest project shown on this year's Euruko, because it has like 3 months. It started in January, in February actually. Okay, so of all the API methods in Ruby C API, half of them is converting to Ruby value, half of it converting from Ruby value, because you sometimes have to get the native type to start the number crunching. Well, yeah, Ruby C API has this crapload of methods. Actually, do you know how long is the ruby.h file? It's about 4,000 lines. Imagine that probably 500 of them are methods for converting this, well, probably more if you include the defines and preprocessor. In RuDy you have one method, or actually it's one template. The bang in D indicates using the template, because again, at compile time, you just give the compiler information that you want the template to apply to the given type and return the given type to your D application. And as the proper argument, not the template but the function argument, you pass the Ruby object. So it's already cool. If you downloaded the codes, you could see the. I'll show you anyway. So you could see the working example in examples example2.d. These are, you know, some functions using the toRubyValue. They work. In the directory there are also Ruby files and tests for it. And you can see some D-type templates in action. This is ugly code because this is a code in a low-level language. It's still better than corresponding C code, as you can see from the slides. So, how about some nice wrapping? If you have an object-oriented language, we could wrap some stuff into objects to do some operator overloading. Oh, I haven't mentioned to you that D has operator overloading. Actually, that was intentional. To compare it the way it should be compared, not comparing like C forces us to do. And it has also a pretty cool template, which is not mature enough, but it's already a bit working for simple cases. To add a C method in Ruby through a Ruby API, you have to first grab the reference or create one to your class or to your model, then call an appropriate method. That is define method for class methods, define model functions for module methods or module functions, and do all this, all this code that if you did some native extensions, and you don't know you're happy if you didn't. Well, in RuDy, you just call it with a name or class or module, the symbol, the reference to the method, and RuDy does all the rest for you. So if you could combine it, it would be cool to have a native pure D function that would be declared as taking native D types with arguments coming from Ruby, converted automatically from Ruby to D, and then fed into this function. And that function that would return a native D value, so you could use it also in your native D applications or native C applications. And then on the exit converted from D to Ruby again, so you could pass it back to the interpreter. And also defined by def bang. And all of this, of course, automatically, because it would be cool to just, copy paste some existing code or just take some C library and just def bang it and have it available. Well, it's possible in D using these features. It's in PyD, so Python guys already have it, lucky bastards. I'm working on it in RuDy. It's going to be there probably in a few weeks. As I told you, it's a very young library. So it would be also cool to wrap not only functions, because we're object-oriented. It would be cool to also have a full D class exposed to Ruby, looking like a Ruby class, by a simple def bang my D class with all the public methods wrapped by def method and exposed to Ruby. Again, it's in PyD, lucky bastards again. We're going to have it soon as well. So there are a few features I would like to do. Actually, I would like some feedback because I've been doing RuDy for myself, but I don't really have an idea what to implement next or what would be convenient or what even function names would be convenient. So it would be cool to have, for example, a this function or delegate or closure, because D has closure, to be passed to Ruby value and converted to a callable Ruby proc or lambda that you could, just to Ruby value, just some brackets with some working code, and then in Ruby do this thing .call. It would be cool. It will be there. It's in Python already. Great. It's actually the biggest blocker to have a sensible build system with a d-aware xconf. It requires some makefile foo and so on. And a few features, like for example, making up for some of the problems with D, which actually are not the fault of the language, but the fault of the ecosystem. Like D has now 3 compilers, and each one of them has its different flaws. And D could also use some fellow developers. Not that I would expect you to do anything. So if you want to get it, it's on GitHub. You can clone it. You can read a bit about it. Before you bash RuDy or kill me with your questions, I'm sure you will anyway. RuDy is young. It's far from 1.0. So features described or covered with tests in the project page are working. They are tested. And I think you can use it, maybe not in production yet, or if you can use it in production and find maybe some bugs, maybe you could help me a lot. So I can attest only for the tested things, but RuDy still needs a lot of work, as you could see on half of the slides. So remember the rules of metal, and the main rule of metal is, yeah, that's right.
There is only one rule of metal. Play it fucking loud!
Well, in case you don't know it, this is Fur TV, one of the greatest shows that ever was created. It's one of the few watchable shows on MTV. So that's why it's so late. It's like after Date My Mom, after everything, after the Tila Tequila and so on. It's very late because it's watchable. It's good. Okay, so thank you. I think it's time for some questions.
Any questions?
Hello. Can you recommend any examples where we can go and learn more and look at some code?
Yeah, they're on GitHub. If you clone it, you have the examples directory.
Okay. But do you know of any like tools that already use it beyond examples?
No, I don't. Well, actually, the state that I've shown you of the library is like 2 weeks old. So I think we should give fellow developers some time to pick and use.
Thanks.
Okay, who's metal enough also to ask?
Okay.
Basically, what's the difference in performance between D and C? Do you lose some performance by using D?
Well, if you go to the Debian language shootout, the aliot Debian org, don't remember the exact address. You can check. You can actually set for comparison D compilers, C compilers, C++ compilers in a set of micro benchmarks that they have created. And you can see that D and C++ compilers already rate quite equal. There are a slight, like a few percent differences, sometimes for D, sometimes for C++, but they're actually pretty equal. And just like I told you, D is 2 years old, C++ is 20 years old, so there's still room for improvement. And I think that if you're using only the close to the metal features, that if you're not giving it I'm waiting. If you're not using the object-oriented features to, and if you're just using, if you just copy paste the C code into the D code, I think it's going to rate equal. Sometimes it could even be faster, as shown on the D side. Some specific applications using some specific D elements, like so-called string and array slicing, where you just limit the width of the pointer to the data without copying it, actually make D possible to sometimes even outsmart C. For example, the fastest XML compiler in the world is in the D standard library because it uses this funny string slicing. So that's why it's metal, right? Wait for the mic.
Okay, this is not a question about RuDy itself, but I'm curious why you consider unit testing a language feature.
Why do I what?
Higher level, I would say it's on a higher level. You mentioned that C doesn't have unit testing and D has unit testing.
Well, D has unit testing, yes, that's right. D has the assert method, which basically tests if the argument is true or false, so you can do all the mangling inside it. And D has a cool feature called context blocks. When in any file, in any library, any source code, you can wrap some code into the unit test block, and then if you run the compiler but with option unit test, it's going to only compile. It's going to compile everything, but only run the thing in the unit test. It's going to run all the assertions in the unit test. So it's a very thin layer actually above the compiler and above the low-level language, but it has unit tests in the language, in the specifications. It has them out of the box. Is it cool enough?
How mature are the decompilers? Do you still run into some weird behavior from time to time, or are they very stable?
Well, these are two different questions. Because decompilers are young, and there are 3 actually decompilers, each of them having their own issues. For example, there's the official decompiler, DMD, the Digital Mars, and created by Walter White, which is actually sort of reference implementation of the compiler for D. It's great, it's stable, it's production ready. Only has one flaw. It doesn't do Unix shared libraries. So it basically sucks for us. So there's the GDC, part of the GCC project, the GCC decompiler, which does the shared libraries. but actually stopped being developed like a year and a half ago. So it's not up to date with features, new features of D, because D is still evolving. It's not up to date with some of the features even of the GCC backend. And this project is, I'm using it in RuDy at the moment because it's the easiest one for me to set, because it has the same syntax and front end as the GCC. But I'm going to drop it because this project is dying probably. And there's the new kit on the block, the most promising one, the LDC. This is the LLVM decompiler, based on, of course, LLVM backend. That's probably going to, that as far as I've heard, makes up for all the problems. Already supports a very large set of features. And I haven't tested it yet, but as far as I know, because D has specs, D has a very strict specs. And if you want to do a decompiler, you get the specs and you adhere to them. As far as I know, LDC, while being like 0.9, is already considered production ready if you're using the features it implements. But yes, if I have to show the one flaw of D, it's the compiler hell, because there are 3 compilers. One doesn't do Unix shared libraries. One's development's pretty stalled, and one's actually doing up for all the remaining ones, but it's very young. It's the only problem with D at the moment.
Questions?
I think it's enough metal for today.
Okay, thank you.
Thank you.